Today we're going to go through lesson 5.7, inequalities in two triangles. Remember lesson 5.6, we dealt with just one triangle. Now we're going to throw a second triangle in, and we're going to make comparisons about an included angle, and we're going to be exploring the size of that included angle, and then use that to figure out the lengths of the third side in a triangle. And that'll make sense as we go through some of the problems and some of the videos. So first, let's take a look at the solve it activity that starts off this lesson. Think of a clock or a watch that has an hour hand and a minute hand. As the minutes pass, the distance between the tip of the hour hand and the tip of the minute hand changes. So in this case, this is this distance, x. So we have two sides of a triangle that never change, or the lengths of the hour hand and the minute hand never change. However, the distance between the tips of them does, depending on where the hour hand and the minute hand are. It says, what is the order of the times below from the least to the greatest length of x, and how do you know? What affects the length of x? Well, what affects the length of x is the time. And more importantly in geometry, what is the angle between the hour hand and the minute hand? So the angle formed by the hour and minute hand affects the length of x. As the angle gets larger, the length of x from tip to tip increases, and as the angle gets smaller, the length decreases. So we're looking at each of the times on the clock, and then we're going to order them from least to greatest length of x. So in other words, the smaller the angle, the less length that x has. So 1 o'clock, there'd be a very small angle. So the distance between the tips of the hour hand and the minute hand is very small. But all the way over here at 5 o'clock, it's a very big angle. It's an obtuse angle. So the distance from tip to tip is quite large. So that leads to theorem 513 in your book, which is called the hinge theorem, which is called the side angle side inequality theorem. But we call it the hinge theorem because that kind of explains more what's going on. So let's take a look at this video.
What is the hinge theorem? To help us understand the hinge theorem, let's go ahead and start by recalling a congruence postulate, and we can go from there. So let's recall the side angle side postulate. Well, this congruence postulate states that when we're working with triangles, if we have two sets of congruent sides and the included angles are congruent, then the triangles are congruent by the side angle side postulate. So let's say we have these two triangles, triangle ABC and triangle DEF. Now let's say that side AB is congruent to side DE. So those two sides have the same length. And let's say that side BC is congruent to side EF. So those two sides have the same length as well. So we have two sets of congruent sides. Now, let's also say that these included angles, angle B and angle E, are congruent. So they measure the same. Now, according to the side angle side postulate, we have two sets of congruent sides, and the included angles are also congruent. So by the side angle side postulate, triangle ABC is congruent to triangle DEF. Great. Now, what if we play around with this a little bit? Take a look at these included angles. Say we still have the two sets of congruent sides. But what if these two included angles aren't congruent? What if one is larger than the other? Well, what happens then? Well, we actually have a theorem that talks about it. It's called the hinge theorem. So let's go ahead and take a look at the hinge theorem. The hinge theorem states that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the triangle with the larger included angle has the longer third side. So let's go ahead and see this with triangles. Let's say that we have this triangle right here and this triangle right here. Let's call this triangle PQR, and this one triangle XYZ. Now, let's also say we have two sets of congruent sides. Let's say side PQ is congruent to side XY, and side QR is congruent to side YZ. Now, take a look at those included angles, angle Q and angle Y. Now, what if these two angles are not congruent? What if one of them is larger than the other? Well, the hinge theorem states that the triangle with the larger included angle will have the longer third side. So say that angle Y has a larger measurement than angle Q. Well, by the hinge theorem, that would mean that this third side, XZ, of this triangle is longer than the third side of this triangle, PR. So we could say this: side XZ is larger than side PR. That is what the hinge theorem tells us. Now, to help us see this a little better, think about a door. Imagine attaching a rubber band from the door handle to the frame. So let's say that here we have the frame and here we have the door, and we attach a rubber band from that door handle to the frame. Now, the further we open that door, the more that rubber band will be stretched. And notice what else is happening. This angle between the frame and the door is getting larger. As that angle between the door and frame gets larger, that rubber band gets longer. That is looking like the hinge theorem. Here we can see that's what's happening. We have two sets of congruent sides, so those two side lengths are staying the same. But that third one is changing, depending on this angle over here. So if this angle is larger than this angle, then it makes sense that this third side will be longer than this third side. So now we know about the hinge theorem. If we have two triangles with two sets of congruent sides and one included angle is larger than the other, then the triangle with the larger included angle has a longer third side.
Let's take a look at an example that kind of illustrates that. The diagram at the right shows a pair of scissors in two different positions. In which position is the distance between the tips of the two blades greater? And then use the hinge theorem to justify your answer. So we have the same pair of scissors. One of them is open at a 35-degree angle. One of them is open at a 40-degree angle. So we have this side of this blade congruent to this one. We have this side congruent to this one. So we have two congruent sides, and we're comparing the included angle, the angle in between. So this is 35, this is 40. The question is, in which position is the distance between the tips greater? Well, the bigger the angle between the two sides, the longer the third side. So in this problem, this pair of scissors would have the greatest distance between the tips of the two blades. And if you want to write the hinge theorem into your notes, it is theorem 513. This can be found in your online textbook as well. But if you want to pause the video and write this theorem down, the hinge theorem, you can do so now. Now let's look at an application of the hinge theorem.
In this problem, you will use the hinge theorem. Which of the following statements must be true? Your choices are A. The length of segment AS is less than the length of segment YU. B. The length of segment SK is greater than the length of segment YU. C. The length of segment SK is less than the length of segment YU. Or D. The length of segment AK is equal to the length of segment YU. Remember, the hinge theorem states that if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. How do you apply the hinge theorem? After you identify the angles included between the pairs of congruent sides, locate the sides opposite those angles. Segment SA is congruent to segment YO. And segment AK is congruent to segment OU. So, the triangles have two pairs of congruent sides. The measure of angle A is 90 degrees, while the measure of angle O is 70 degrees. So the included angles, angle A and angle O, are not congruent. Since the measure of angle A is greater than the measure of angle O, segment SK is greater than segment YU by the hinge theorem. The correct answer is B.
Finally, let's look at one more problem that you're going to see in your Math Excel homework. This takes a little bit of algebra, and it takes some work with inequalities. And solving inequalities is just like solving equalities. And today, it'll be fairly straightforward solving. So let's take a look at if we're asked to find the range of values that an angle might be, or that a value of x might be.
In this problem, you will use the converse of the hinge theorem. What is the range of possible values for x? Step 1. Find an upper limit for the value of x. How do you put upper and lower limits on the value of x? Use the largest possible value of the measure of angle TUS as the upper limit for 5 times x minus 20. Use the smallest possible value of the measure of angle TUS as the lower limit for 5 times x minus 20. Segment UT is congruent to segment UR. And segment US is congruent to segment US, so triangle TUS and triangle RUS have 2 pairs of congruent sides. The length of segment RS is greater than the length of segment TS, so you can use the converse of the hinge theorem to write an inequality.
So what we're saying here is we have these two sides congruent, RU and UT. US is congruent to itself because of reflexive property. And because the lengths of these third sides are not equal, that means that these two angles in here are not equal. We know that if this is 15 and this one is only 10, that this angle here has to be less than 60. And angles can't be any less than 0, so this angle here has to fall between 0 and 60 degrees. We don't know what it is, we're just finding a range, but this angle has to be between 0 and 60 degrees. Let's go ahead and finish the problem.
Use the converse of the hinge theorem. Substitute. Add 20 to each side of the inequality. Divide each side of the inequality by 5. Step 2. Find a lower limit for the value of x. The measure of an angle of a triangle is greater than 0. Substitute. Use 5 times x minus 20 for the measure of angle TUS. Add 20 to each side of the inequality. Divide each side of the inequality by 5. Rewrite x is greater than 4 and 16 is greater than x, as 4 is less than x, which is less than 16.
Which means that for that angle to fall between 0 degrees and 60 degrees, that the value of x has to be between 4 and 16. You'll have a couple of these kind of problems in your Math Excel homework, so when you hit those in Excel, if you're not sure what to do, you can always come back to this part of the video and rewatch it. Okay, that's lesson 5.7 out of your text, inequalities involving two triangles, and our objective was to apply inequalities in those two triangles, and we did that using the hinge theorem. and the converse of the hinge theorem.